Okay, guys, 6.6 is trigonometric form of a complex number. Okay, so we are bringing back complex numbers. What do I mean by complex numbers? Like eyes, yep. Okay, so when we talk about a complex number is something that is of the form a plus bi. Okay, that's what a complex number is. It's something that's of the form a plus bi. Complex number involves the I, the imaginary portion of the number. A is the real part, B is the imaginary part. Now, we're going to do some very basic things, which you may have seen back in Algebra 2 when we did imaginary numbers. And we're going to go and also connect our imaginary numbers to trig form and this polar form we've been working at. So, first thing we're going to do is we're going to graph complex numbers. I feel like I did this back in Algebra 2 with you. Okay? In a normal scenario, the set of axes you're looking at is a x-axis and a y-axis. Well, in complex numbers, this is a real axis and an imaginary axis. Okay? So instead of x-axis and y-axis, the real axis and imaginary axis. When you go to graph a complex number that is in the form a plus bi, realize you're still going to be thinking of it as an ordered pair, and we're going to be graphing it of the form a comma b. So as we look at example A, the complex number is 3 minus 4i. What is that as an ordered pair? If we're thinking a comma b, what is 3 minus 4i? The a value is going to be what? 3, comma, what's the b value? Negative 4, because it's the coefficient of I. So in order to graph 3 minus 4i, you're basically graphing the ordered pair 3, negative 4. Now let's see. Looks like the highest value I see in any of my graphing is 5. So I'm going to put 5 tick marks each direction, just so I can be ready. And in order to graph 3, negative 4, what are we doing? Right 3, down 4, and this is what I'm going to call point A, because it was question A. Are we okay with this? It is really this easy on this portion, I promise. Okay? So what about the complex number negative 2 plus I? What do we think of negative 2 plus I as in an ordered pair? Negative 2, 1. There's an invisible 1 in front of the I, so negative 2, 1. How do we graph negative 2, 1? Left 2, up 1. And that is what I'm going to call point B. Okay. What about C? 5i. What'd you say? 0, 5? Because if I have to rewrite this, 5i is the same as saying 0 plus 5i, right? If we're putting it into that a plus bi form. So yes, this is the ordered pair. 0, 5. Where is 0, 5? Left or right 0 and up 5? That's what I'm going to call point C. And what about point D? Negative square root of 3. Yep. And, you know, if you're thinking about a plus bi form, it's negative square root of 3 plus 0i. So it is negative square root of 3, comma 0. Do you know the square root of 3? Do we know that estimate? Because you're going to need an estimate to graph this. Square root of 3 is approximately 1 point. What'd you get?
3205.
Okay. So I can't get very official, so I'm going to say negative 1.7. Because I can't even really graph 1.7 very precisely. So the ordered pair negative 1.70, so I'm going to go left 1.7. And I'm going to call that point D right there on the x-axis. Okay. Question about the basic graphing here. Okay. That's like what? Difficulty level 0 maybe? Now you do have to know your left from your right, so maybe difficulty level 1. I don't know. Okay. Let's go and look at part 2. Part 2, I think was also in Algebra 2. I'm trying to remember. I feel like it might have been. But this is how to find absolute value of a complex number. When we talk absolute value, okay, in just a normal plain regular real number, absolute value is just the distance from 0, make it positive. In a complex number, it's not quite that easy. So in order to do absolute value of a complex number, we have a formula. So the absolute value of a plus bi, the formula is the square root of a squared plus b squared. Okay? Now, and that of course means that a is the real portion and b is the coefficient of the imaginary portion. So, in order to do the absolute value of 3 plus 4i, think it's the absolute value of a plus bi. And the formula you're doing is the square root of a squared plus b squared. Okay. There you go. I'm going to say equals square root. That's what I'm going to give you. The square root of, what is a? A is 3. So 3 squared plus, what is b? The 4, yes? Is the I included as part of b? No, it is not. Because it's bi, so the b is just the number in front of I. So it is just the 4. So square root of 3 squared plus 4 squared. Well, 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. The square root of 25 is 5. Okay? That's the basic example. B, the square root of negative 2i. Well, what is a here? 0, yes? Because this is like saying the absolute value of 0 minus 2i. So a squared is 0 squared plus, what's b? Negative 2. So negative 2 squared. Now, folks, I need you to be smarter than this. 0 squared is 0. What is negative 2 squared?
Negative 4.
Shush it. Negative 2 squared is 4. Positive 4. And the square root of 4 is 2. I have to have you guys knowing that, okay? I don't think you're one that has made this mistake on Quiz is a test, though. Okay, what about C? What is A? Okay, A is that negative square root of 2, so negative square root of 2 squared plus, what is B? There's no I part, there's no imaginary part, so it is 0. Now, yes, this could be written as the negative square root of 2 plus 0i, but this is also just a real number. I'm actually doing way too much work on that, but I'll talk about that in the end. Okay, what is the negative square root of 2 squared? When you square square root, you just get whatever's under it, so it's going to be 2. Plus 0 squared is still 2. What's the square root of 2? We're just going to leave it as square root of 2. You can get a decimal if necessary. Now, that answer should make perfect sense based on the absolute value you learned back in elementary school. This is just a real number, isn't it? What's the absolute value of a negative? A positive. There's no I value, so we did the formula out of habit, but we really wouldn't have had to. In all honesty, I started setting it up before I thought about that, so my point is it works both ways. And D. Absolute value of negative 1 minus I square root of 5. Okay? Square root of, what's A? Negative 1, quantity squared, plus, what's B? The negative square root of 5. Pretty much everything but the I, right? So negative square root of 5, quantity squared. Okay, well, negative 1, when you square it, is going to be 1. Negative 1 times negative 1 is positive 1. Square root of 5. What do you get when you square square root of 5? You get 5. When you square a negative, you get a positive. 1 plus 5 is 6. What's the square root of 6? I'm going with square root of 6. Okay. Does that seem familiar from Algebra 2? I feel like we did that in Algebra 2.
I don't think so.
Huh? It's easy either way. Fair enough. Okay. So, I don't know. Was that still level 1 difficulty? Maybe level 2 difficulty. I don't know where these levels are coming from, but okay. Moving on. Okay. The next part. The whole point of this lesson is we're connecting trig form with complex numbers form. Okay. So we had to learn about absolute value before we could really get into it. So, in order to find trig form of a complex number, okay, now z is what is often used to represent a complex number. Thus, at the top of the page, you saw z equals a plus bi. This formula right here, it's what is going to help us to take a complex number and put it in trig form. Okay, or that is our trig form, I guess. These other pieces are going to help us. So that is when you're asked to take a complex number, like one of these A, B, C, D parts, we're trying to get it into this form right here. Now, what do you have to know to get it into that form? You're going to have to know R. Do we have formulas to find R? We do. Okay, we have a formula to find R that we're going to talk about. We also have to be able to find theta. Do we have a way to find theta? We do. These formulas should look a little familiar to what when we first learned how to convert rectangular coordinates and polar coordinates. They should be very familiar, right? Okay, so let's look at A. A gives us the point that z, complex complex number of 1 common, strike that, 1 minus I. 1 minus I, yes? Now, where my brain was going with that is, what is the ordered pair for 1 minus I? Just based on what we did up above, 1 minus I is the same as saying 1 negative 1. Okay, because that's going to be helpful in a moment. Quick little visual. Where is 1 negative 1? It's going to what? Write 1 down 1, so it's going to be down there in quadrant 4, yes? That visual is going to be necessary when we get to the angle. Okay, so we need to find two things. We need to find R, we need to find theta. What are we going to do to find R? R is absolute value of the number, so a squared, square root of a squared plus b squared. Square root of, what's a? A is 1, so 1 squared, plus, what's b? Negative 1, so negative 1 squared. 1 squared plus negative 1 squared is 2. And we're under a radical, so it is square root of 2. Okay? 1 times 1 is 1. Negative 1 times negative 1 is 1. 1 plus 1 is 2. Okay, we have our R value. Are we good there? Now, we need our theta value. In order to do our theta value, notice it's tangent theta is equal to b over a. So tangent theta is equal to b over a. What is b? B is negative 1 over a. What's a? 1. What's negative 1 over 1? Negative 1. So I want to know, where does tangent equal negative 1? Now, in order to do that, what do we generally try and do? We try and start with, okay, where does tangent equal positive 1? Where does tangent equal positive 1? At pi over 4, yes? Is that the question we were asked, though, officially? No. Okay. I'm going to come up here for a quick visual. So, pi over 4, but we want which two quadrants? Okay. Pi over 4 is quadrant 1. We want to know where tangent is negative. Which quadrants is tangent negative? Quadrant 2 and quadrant 4. What is the pi over 4 angle in quadrant 2? Three pi over 4? What is the quadrant 2? What is the pi over 4 angle in quadrant 4? 7 pi over 4. So officially, my theta values are 3 pi over 4 and 7 pi over 4. However, I only need one. Both of those are valid points, but I only need one. Do I want to use 3 pi over 4 or 7 pi over 4? 7 pi over 4 because when we first started this problem, where did we decide this point needs to be? Quadrant 4, yes? So right here, we need to be in quadrant 4. Which one of these is in quadrant 4? 7 pi over 4. Okay? 3 pi over 4 is valid for the equation we are solving, but it's not what I need. Okay, guys. We just have to write our equation. We are writing the form, or the number, the trig form of the complex number, z equals, going back to this original form here. What is r? Square root of 2 times parentheses cosine of theta. What am I using for theta? 7 pi over 4 plus, oh my goodness, huge typo. Huh. Is there an I right there in your guys's? Huge typo. Thought I had it fixed. Obviously not. Trig form of a complex number is supposed to be r times cosine theta plus I sine theta. Sorry. I just realized I'm like, that wasn't up there. So, next thing we're going to write is I times sine of what was theta?
7 pi over 4.
7 pi over 4. Okay, guys. There's your final answer. And yes, my apologies, there was supposed to be an I in there, and it's not even written in my notes. What am I doing? Gosh. Okay. I think that's our stopping point, isn't it? Okay. So, we have those 3 tomorrow, and then we'll look at an example on the back. I would like to think you'll have a little bit of work time tomorrow, but I don't know. Never know.